Alright, so today what we are doing is looking at differentiation. But instead of y equals a function of x, what we've got is x as a function of y. Alright, so example might be something like this. So, for example, x equals, say, 4y squared plus 5. And we want to differentiate something like that. So, the technique we use is to find dx dy, whoops, dx dy, not dx dx. So we'll differentiate x with respect to y, and then flip to get dy dx. So mathematically, what that would be is that dy dx is 1 over dx dy, provided of course dx dy is not equal to 0. Of course, if it is, then it's not defined. So let's have a look at an example, or some examples. So we want to differentiate going to use that one over there, 4y squared plus 5, to find dy dx. Alright, so the technique, as I said, we will differentiate x with respect to y. So if x is equal to 4y squared plus 5, if we're doing the derivative with respect to y, 4y squared would become 8y. And of course the plus 5 becomes 0. And then we flip. So think of that as over 1. So dy dx is 1 on 8y. And of course, there's a restriction there that y can't equal 0. Alright, so we can find gradients of curves and things like that by using this technique. So we've been asked for the gradient. Now gradient is, right, gradient is dy dx. Alright, so always dy dx, the gradient. So that means that we're going to have to use this technique here to differentiate to find dy dx. And we'll worry about the y equals 3 later. So if x equals y squared minus 4y, when we differentiate this with respect to y, hopefully we get 2y minus 4. Correct. Think that is over 1. Flip to get dy dx, which is what we're after. We're after the gradient. So that's 1 on 2y minus 4. And so now we want the gradient at the point where y is equal to 3. So I don't need the x coordinate because this gradient here has y in it. So we now got to substitute y equals 3, and so the gradient, which is dy dx, is 1 over 2 times 3 minus 4, half I believe. Yes? All right. All right, so sometimes you might be given different bits of information. And so this next example, when the information we're given is different to what we've done there, even though it looks like it's the same. Alright, so while on the surface it looks like it's the same kind of equation, but this time the information about the point is different. Alright, so what we need to do then is we need to go, okay, the gradient is the same equation as there, so x equals y squared minus 4y. Our gradient, as it will be 4, which is dy dx, is 1 on 2x, 2y minus 4. Alright, so that's not different, that's the same as it was before. However, this time we've been given an x value, haven't been given a y value, so we need to then find the corresponding y values. Alright, so when x equals 5, then we've got 5 equals y squared minus 4y. So we then take 5 and we get y squared minus 4y minus 5. Then what are we going to do? Factorise, well done. And what are the factors? Two numbers multiplied to give us minus 5 and add to give us minus 4. Is that right?
Yeah, the bracket should have
Oh, I should have Y's in them, not X. See, I made a mistake down here too. My notes should be Y's. See, too used to doing X's, aren't we? Thank you. Rookie mistake. Someone my age shouldn't they make a mistake like that, should they? Alright, so Y is 5 or Y is -1. Alright, so it looks like we've got two possibilities. So we've got gradient of 1 over 2 times 5 minus 4, which would be a sixth, or 1 over 2 times -1 minus another 4, which would be -1/6. So, just as a matter of information, what do you think this graph here, if we graphed it, what's it going to look like? Do you think? We've got a square there, so a squared would suggest a parabola, but this time we've got the y squared, not the x squared. It's a sideways parabola, yeah. Alright, so just as a note, this graph is a sideways parabola. And so because it's a sideways parabola, then we're going to have two y values. For each x value. Alright, and this particular one has intercepts there and there. This one up here is at 4. And it goes around like so. And so x equals 5, which is up here. There's our two x values that we're talking about. So gradient of 1/6. There's our two y values. So 1/6 is this one, and -1/6 is that one. Alright. Anything about that? Alright, that's it. 6B.